On today's episode. So today's project is an upgrade of this old Bosch drill. Now we've been together for quite a few years now, and it functions very well, and I'm loath to throw it away. The only fault with it, which is very common, is that the original batteries have basically died. The 12 volt 2 ampere hour cells, no surprise if you get inside of the guy to find that they're fairly standard nickel cadmium cells, 2 ampere hour, no markings on there, but I suspect they're possibly Sanyo. They were very good back in the day, but that was back in the day, and now they don't hold their charge, and we could do with something with a bit more oomph in it. So we've got to change this battery pack out. Now I've been through this exercise already with lithium cells, and I tried first off with a standard sort of hobby style cell. Okay, this was only 1800 milliampere hours, but I thought that was near or thereabouts. Unfortunately, it wasn't really up to the job. As we can see, the cell has been vented under the abuse, so that's not going to fly. So once again, dipping into my stock of cells that I've recovered from old laptop batteries. What I have here are, in fact, not sure if we can see that there, focus, but these are Sony cells, the US 18650 GRs. Now they're nominally rated at I think 2600 milliampere hours, so that should be in the right ballpark, and we can get three pairs, so these are in parallel, so that should give us nearly 4000 milliampere hours, and we've got plenty of room in the box to stack those somehow in there, and get the top on still. What I'm going to do is to recover this balance charge connector, because we're going to need to do that to balance charge these cells. Okay, you can get away with fast charging or just charging without the balance connector at a push, but to avoid things like this happening in the future, then it's a very good idea to use the balance connector and the proper charger with that function. So without further ado, let me get the balance charge connector off of this cell. So what we're going to do is to get inside the cell here, as we can see, taking off the old cover, and we're going to remove the XT60 connector, as I'd thoughtfully put one on the cell, the battery pack before. So we're going to remove that, and obviously the balance wires. So now, breaking out the faithful Weller iron. Get some heat into the joint there. No. So there's the first connection off. Into the middle now. I guess it might be an idea, having seen these cells explode on YouTube. I did watch a very interesting documentary on the PBS channel on the making of the new super batteries, driving nails into these things and all sorts of nonsense. So that has separated the main power connector and the balance charge connector from the old cell, and this will be disposed of in an appropriate manner. Our local town hall, our local ayuntamiento, has a disposal place for batteries and also for fluorescent tubes, which is quite advanced, I think. So I'm just working out the general arrangement here. So these cells, as I say, they've got the original tabs on, so they've always been paralleled up, so they'll be matched well. And if I put them in this sort of fashion, just basically roughing things out, make sure things will fit. I'm going to do, I've put a hole into the bottom so I can take the balanced charge plug out through there, and just check that I can get this connector in as well, and that will sit on the top there. So that's the general idea. So I'll get the battery pack soldered up and get that fitted in. I'm not going to bore you with the entire soldering process, just a couple of observations on the way. I've put a couple of blobs of hot melt glue just to keep the cells together whilst I solder them. Yeah, functional if not aesthetically pleasing, I think we say. What I'm going to use to join the cells is just some solder braid, some solder wick that you use for getting solder off of old circuit boards and such like, but that will be able to pass enough current, I think, to do what we need to do. And I've already cleaned the contacts up. I usually just scrape the tops there with a scalpel blade, and then apply a little bit of liquid flux. That's this stuff here. I'm sure wherever you are you can get something similar. So just a dab on there. Try to seal that down, stop it evaporating. Now with a nice hot cleaned iron, tin the iron first, apply a little solder as quickly as possible. Both sides. You can see it's nice and shiny. Shiny is good. And then just finally tack the braid across, so just going to tack that one onto there. Of course the braid has flux in it by its very nature, so we don't need to concern ourselves with that. Just clip that piece off there. Make sure that that's, keep that down whilst the solder reaches its eutectic point. Now that's the point where the tin solder lead tin solder mix actually solidifies. It's called the eutectic point. So I'm just going to repeat that process for the rest of the connections. So here we are back in Battery Central. And what do we have here? A new kid on the block, or at least for me around here. Before I knew whether I could repair the other iMax charger, I was looking around and found this guy on offer. And I think the model's possibly a couple of years old now, but I'm a sucker for graphical interfaces, and it's got a touch screen as well, so I think it's rather neat. I do believe on the RC Groups forum that it has a bit of a checkered reputation, perhaps not being very reliable, but I'm going to check that out myself. And if anybody's interested in a more in-depth review of this guy in the future, then please leave leave a note back down in the comments, and we'll get to that. But we can see that we're charging the pack that I've just made up. We're giving it a fast charge at 1.5 amps, and we can see the lower curve is the milliampere hours. The green curve is the current, so that's constant current mode, as we can see at the moment. This is just a temperature sensor inside the unit, and we can see the output voltage there, 12.21. Obviously that's climbing up now, and we have the individual cell voltages along the bottom. It's obviously connected up via the battery balance cable as well, and we can see that as time inexorably moves on, the graph changes, and we'll be able to see at the end of that charge what sort of milliampere hours we've put in. So here we can see the screen as the charge is terminated, and it's quite a neat display. I think we can see the voltage at the top there. Obviously the charge has terminated, and that's 2,408 milliampere hours, and you can see clearly the end of charge sequence as the voltage of each of the individual cells came up to 4.2. The current ramped down, and I really like that graphical display. You can tell a lot about what's going on from just a quick glance at the graphs. Well, if you've been looking at charging and discharging curves of batteries for as long as I have, you can anyway. So here we have the battery pack just lashed up now to the drill for a quick test. We're locked and loaded with a 10mm wood bit, so I've got a bit of scrap wood. Let's see. Yep, so life in the old dog yet. Quite literally.